Greetings and welcome to another installment of some introductory SolidWorks techniques. And in this example, we are going to create the saw blade. Now we've already made the saw handle, and you may have made the rivet as well. Saw blade is not a complex part. In fact, it has one essentially simple cross section, this entire sketch. But we're going to do it in a few parts here. I'm going to have particular reasons for doing it this way, so please follow along with my example. So I've already started a new one. So I opened up the part, I saved it up here, and notice how I also made sure that it was in the unit system I'm looking for. Now, one of the things about this, again, is to plan it out. I'm going to recognize that the saw blade has a little bit of symmetry left over from the saw handle. So what I'd like to do, note we've got the front plane, top plane, right plane. Well, I'm going to, again, use the front plane, which is the same, essentially the same plane. I'd like to make it the same plane, exactly, that we would assemble into the handle. So that one was the front plane. This one will be the front plane. So I'm going to go to Sketch, click on Sketch. Since I've already selected the front plane, it will be that one. I was using this before, so that's why it looks a little offset. So I'm just going to not worry about that, and I'm going to create center lines. Now, you could righteously maybe use the origin as the lower left-hand corner because there's not a lot of symmetry in this part, but I'm going to use it in this situation kind of right down the middle, similar to the handle, in part because the handle is done in this kind of a fashion. I'm going to use this center line to line up the holes that I have, similar to the way I did it in the handle. Well, here is my line. I'm just going to just do the general shape like this. Notice how I'm using these blue lines that show up here, these dotted lines, to help out. And once I'm done with this section, now notice how I have a full, complete loop here. That doesn't mean I can't make other loops. So I can make circles. Now each one of these circles is also a complete loop in itself, as long as these loops don't cross. So doing something like this would cause problems for the computer in generating it, so we never want to have these lines cross. I'll go over that some more in a bit. So to make some of these relations, I'm going to make that line, that center line, and that line into a symmetric relation, so that this line and this line are always the same distance to the center line. And that also has a overall dimension of 6. So this line will always be 3 inches from here, and this line will always be 3 inches from here. Now there's another dimension for the center of that hole. I'll make that 0.63. So it knows where those centers are. So now I can't move that up and down because it knows where it is with respect to this line, and this line is known with respect to this line, and this line is on the origin. So these won't move. Now why are they still blue? It's because we don't know the size. What's more, if I move this one doesn't change. I want to make these two equal. So click on this, click on that, make them equal. Dimension them up. they are supposed to be 0.38. Then we had a distance from here to this line. That's 1/2 inch. And this line overall. Sometimes this pops up because I forgot to not select this line, deselect this line. So just click there, 1 inch. So if you missed that, do it one more time. Just selected this line after a smart dimensioned, and it's 1 inch. All right. Now, this circle, still don't know where it is. That's because we should have made it symmetric with the other circle to the center line as well. So we'll do that. And for that, I will want to choose the center of the circle. Sometimes it doesn't matter which one you pick, but in this case I was going to choose the centers. And now that one has turned black. So we're all set in this section, but not over here. Put the big dimension in of 18 inches. Oh, got to zoom out. Remember, I get to roll my mouse button here. And then finally, that height is 1.5 inches. Okay, let's just neaten this up a little bit. Move this out here so we can see it. Move that there. Now you might be wondering, why am I showing 0.38 in D3 and 18 in D6 and so on here? And yours probably does not show that. Well, the answer is up here in the View menu. The View menu allows you to see a whole bunch of different things. And I had clicked on dimension names to view a while back. So each one of these dimensions has a name within its sketch. So the name of this one is actually D2 at sketch 4. Why is it sketch 4? Because I made some earlier sketches that I deleted, and so it came up with the next one, which is sketch 4. So this one is D1 at sketch 4. So we're going to finish this one off. Looks pretty good for now. And there's sketch 4. This is the basic outline of our saw blade. Now I'm going to go to Features, click on Extruded Boss Base. We get this yellow message in that we have to select another plane on which to sketch the feature cross section, but I already sketched the cross section, so I'm just going to click right here on the cross section, or I could click right here on the sketch. Either one will work. And now it is asking me what kind of extrusion I want to make. Do I want to make it blind, vertex, and so on? I want to make it mid-plane because there's symmetry right down that middle of the part. So I want to use mid-plane, and this shows 0.09 on the drawing, so I'll use that. And now I have mid-plane, 0.09 inches. I don't need anything else here, so I'm going to hit my green checkbox, and I have my first feature here. In the drawing, we still have 2 features yet to go. Well, actually a lot more than 2 features. For starters, we have a radius that we need here. So I can click right on that edge, go up to fillet, and it's supposed to be 0.25 inches, which was in there before, so I'm going to take that 0.25 inches. There's only one edge I need to worry about. This is a constant size fillet. There are these different types of fillets which are fun to play with, but I'll let you do that on your own time. And it shows a full preview right there. Looks good to go. Now another way of making this fillet, which would be perfectly fine, is to do it within the sketch. So I'm going to show you what happens when I take away the edge of a fillet. right click here, and I'm going to go up to Edit Sketch, and I'm going to go to this, which is making a sketch fillet. I'm going to click on this line and click on this line, and here's the fillet. And enter in 0.25 in that spot, and looks good. Notice that this dimension is dimensioned to the intersection of the original two lines, which is pretty handy if that's what you're looking to do, and it is in this case. So now watch what happens when we obliterated the edge that this fillet was supposed to be on. So I'm going to accept my sketch that I modified from the first extrusion. Oh no, a pop-up comes here and it says some filleted items are no longer in the model. That's fine. I'll hit close, and you see a little error here that this was not able to be produced. So all I'm going to do is right click on it, click the delete button. We're going to confirm the delete, and it's going to tell us if there's anything dependent on it, which is a good thing because we could get rid of a whole bunch of stuff we didn't mean to, but there's always the undo button. So we want to get rid of this, and we are left just with the sketch and the extrusion. So now all that's left are the teeth. Well, there are a variety of ways of dealing with the teeth. I can right click on the actual feature and I can go right up to Edit Sketch or Edit the Feature, or I could use that plane to make a new sketch right there. So there are a lot of shortcuts to some of the techniques I'm showing you. So I'm going to go back to Edit Sketch. I'm going to make it come back around to the front face here. I'm going to zoom in here. Now I could have sketched in a tooth and then sketched in another tooth and then another tooth all through here, and it would have been an absolute crazy mess to dimension every single one of these. I'm going to select all of those teeth, delete them. Another thing I could have done is created one tooth and used a linear sketch pattern or a circular sketch pattern. Now, using the linear sketch pattern, we could make a whole bunch of these right down the line and it would have worked out for us. But this is not probably the best use of the linear sketch pattern. I instead want to make a whole new feature and use a feature pattern. Linear patterns, they come with some additional work sometimes. Sometimes it makes sense to make something in a sketch pattern. Sometimes it makes sense to do it in a feature. In this case, I'm going to choose a feature. So that was one way of making the teeth. Now, one of the problems is that in this drawing, they say they want 130 teeth. Now, I take that to mean that there are 130 things with points on them. And you say, well, that's kind of obvious. Well, that's not necessarily obvious, because a half tooth would be one with half a point on it that comes right out to the edge here. So it does make you think about what's really being intended. Again, what is the design intent? So an easy way of doing this, not necessarily the best way, but an easy way of doing this is sketching, and we're going to choose the plane of the saw blade here. So that's what this yellow thing is asking us to do. Find a plane or find a sketch. Well, we didn't make a sketch yet, so we got to find a plane. So I'm going to click on this plane first, and now insert a line, and I'm actually going to make it look like this. Okay, and why am I bringing it all the way over here? Well, you'll see in a second. I'm going to dimension this line down here of 0.125. I'm going to do the height of 0.093, which is how it's dimensioned over in the drawing. We'll bring this up, bring this over, and zoom in. Hit escape a couple times. I'm going to drag this over. There we go. Make sure that this line, hold the control key down, and this line are collinear, so it stays right on that line because it was kind of coming off there. There we go. Now they're collinear. And then if I make this and this equal, then it will always be an isosceles triangle. So I can change this to 0.05 if I wanted to. But these two will always remain the same. Hit Control Z, and that's an undo. Okay, so now if I cut through this, I will have cut half a tooth off. And you're still maybe wondering why I chose to do it all the way out here instead of right along the edge. Well, we'll get there. So there's my sketch. I'm going to go to Features, Extruded Cut. I'm going to go through all. Blind still would have worked, but I want to make sure in case we change the thickness that it's going to be going through everything. Hit my green check mark. Everything else looks good. And you'll see that I have cut part of a tooth. Well, do I have to do that again? Do I have to create 130 of these cut extrudes? The answer is thankfully no. I'm going to instead do a linear pattern, and this direction that it's asking for, it can be any edge or line. It has to be linear. That's in your model. You might have to make one, but in our case this time around we have an edge that we want it to go along, and that's great. We want it to go in the spacing of 0.125 that the teeth are in, and this time we'll only do 4 for starters just to see how it goes. And the question is, which features do you want to have patterned? So you have to click down here to make this blue, and I'm going to zoom down here and click on this particular feature. Now I could also go up here, click in that spot, go to Cut Extrude. I'll just click right here this time around, and if I hit my green check mark, you will see that I am making teeth. But the question is here, how many teeth have I made? I've only made 3 teeth. Only 3 things with sharp points. Now, you could possibly argue that this is half a tooth, but that's kind of tough. Also, you could say, well, maybe we should have had this come straight down over here, but I don't think that's a good saw design. So I'm going to make sure that we come out here and start making 3 teeth. Why is that a problem? Well, because if I double click here, I can find out what we were supposed to be making. Here it is. 4 teeth. I can double click on that when I double clicked on the pattern, or I can right click on this, go up to linear pattern, and you'll see I was supposed to be making 4 teeth, not 3 teeth. Now, why is that a problem? Well, first off, we have to make 130 teeth, so I could just tap in 130 teeth. And it has made 130, oh, wait a minute, that's 129 teeth. Well, what's the problem there? I go right up here, and I make 131 teeth, knowing full well that it's actually 130 teeth. What's that a problem with? Well, it's not a big problem, but it does not capture the design intent. The design here says 130 teeth, and that's actually from the database. If I went to put this model into a drawing, you would see that it requires 131 teeth. So how do I make this work? Well, there are a number of different ways of making this happen. Am I making it a little bit complicated? Yes, but I really want to capture the appropriate design intent. So what do I do? Like I said, there are many different ways of dealing with this. So in the interest of time, I'll go and show you what I deem to be one of the better ways. I'm going to pretty much do a copy of the cut extrude. I'm just going to do another feature. But before I do that, so I don't get all mixed up with this linear pattern, I'm going to do something kind of neat. I'm going to do something a little bit different. I'm going to click and grab this blue line, and I'm going to bring it up. That will actually suppress the linear pattern that we made before. All I need to do to unsuppress it is drag it back down. So it's not like I lost it forever, because sometimes it's, some of these are very difficult to do and you don't want to lose them. But this means that I'm going to be creating a feature in between, because it's often important to figure out which feature to do first, then second, then third. So I'm going to make a new feature. And I'm going to do it in part also to show you another technique. Okay, we're going to sketch on this plane again, and I'm going to pick that front to look straight on it. And just like we did before, I'm going to make another triangle. I'm going to hit escape. And oh dear, this somehow made a perpendicular relation. So I'm just going to left click on that, click on the delete key on my keyboard, and it's gone. So I did not want that to happen. So I'm going to go back to Smart Dimension, just like we did before. Click here, go there, and I'm not going to worry about that yet. I'm going to click here, go up here. I'm not going to worry about that either. And I'm just hitting return when these come up. And I'm going to hit escape again, make these two lines equal so that it remains an isosceles triangle. Now I can take these dimensions and I double click on them. I can type in equals, click here, and these two dimensions from the other features show up. And so I want this to, instead of 0.34, I want it to be 0.13. And notice how it has this really a programming syntax, equals open quotations D2 at sketch 5. So this is the second dimension at sketch 5. Hit green check mark and suddenly it becomes that. Now also notice that we have a notation here that indicates that it's controlled by an equation. That's what this symbol means. It doesn't actually mean summation as a mathematical term. It simply means that there's an equation that governs this dimension. So I can do the same thing here. Double click here and look at this. Now if I just double click on that, it'll give the dimension and just fill in that number. But if instead I type equals and then I click on it, this comes up. So I'm going to accept that. That's all I need. I'm going to use this sketch as part of a feature, making an extruded cut just like the other one. I'm going to make it through all and then click OK. And now I've actually made a tooth here with a sharp edge. But let's see what happens when I double click on this and I change the height, say to 0.125 for fun. Immediately the other one changes as well. Sometimes you have to make it regenerate like that. And then there we are. So now we have created an actual tooth, and we have one feature here and another feature here. Now if I make another one of these and another one of these, I will continue making teeth. Well, what I'm going to do is I'm going to bring my linear pattern back, and yes, it's regenerating all the cut extrude 3s. Notice over here, if I put my cursor over linear pattern 2, it looks at cut extrude 3 and boss extrude 2. So I'm still at a situation where I'm making 130 teeth using 131 instances. What I want is I want this linear pattern to reflect the number of teeth I actually want. So I'm going to edit feature. Instead of 131, I'm going to make it 130, and I'm going to look at the other cut that is actually making the teeth. So this one makes the initial chamfer here and defines the different dimensions. But this one defines the rest of the pattern. So this one defines this one, which defines that one. And now I've got 130 on my pattern and 130 teeth. So that is your first foray into the linear pattern. There's also something called the circular pattern and a few other these crazy patterns, and you can play with them if you want to. Hope to make a circular pattern for something soon. Finally, for this part, we're going to make a chamfer. A chamfer is a flat surface breaking up two other flat surfaces. So if that didn't make any sense, it will soon here. We've got two flat surfaces here with kind of a sharp edge. So we want to put in a chamfer. So it's under the fillet. So you could either make a fillet or a chamfer on an edge. And the drawing indicates that we need a 0.03 chamfer. And most chamfers are at 45 degrees, which is splitting the difference between the 90-degree angle here. Some are at different angles, and you can easily specify that right there. We'll just keep it at 45 as the drawing indicates. And now we've got to specify here which edges we want to chamfer. So I'm just going to click on that edge and click on that edge. We can ask for a full preview here. And the yellow indicates that it should be able to do it. So click on the green here, and there is our chamfer. It travels nicely all the way down here. Could we have put a radius on there? Sure, but needed to show you how to use a chamfer, and that makes a little bit more sense in this particular situation. So here is our saw blade. In so doing, this particular model, we first created a sketch, again, focusing on whatever can be made symmetric, followed the drawing exactly to create these dimensions. We used symmetry for the circles and for the top edge and bottom edge. Then over here, we saw how we could use either a feature radius or a radius that was part of the sketch. We also saw how using the sketch radius still allowed us to make this dimension to the intersection of the slope and the vertical line. Then we looked at a variety of ways of creating all of these teeth. Well, what we did was we made two identical features that served different purposes. One cut was to simply start the edge and define the dimensions, and the other one was based off of this one, and we used an equation or two to make that happen. Here are the equations. Then we used a linear pattern to propagate that feature all the way down. I do believe that in this case, the linear pattern is definitely easier to use than the sketched pattern. But again, there are some times when you do want to use a sketched pattern. One more note on these equations is that although I made them equal to something else, I could even make it equal to that times 2, for example. And it would change value and make these twice as tall as this. Now, I don't really want to do that, but when we mean equation, we really do mean some kind of expression whereby a dimension has parameters or functions that determine its value. And so there's a lot of interesting things you can do with that. Finally, we created a chamfer, very basic, straightforward chamfer on these two edges for the purpose of physical assembly. Well, I hope that this helped, and the next step is, if you haven't done the rivet yet, do the rivet, and then we will be assembling.